Welcome back. In the last lecture session, I have discussed about testing and two important types of testing, that is black box testing and glass box testing. And we have studied in detail about black box testing in the last class. Now let us continue testing with the second type of testing called glass box testing. Let us see its important features. So just like black box test, black box testing is not sufficient as specifications are usually incomplete. Hence, code is to be tested thoroughly. In case of black box testing, as we know, it is not tested with the program loaded onto the system. Hence, it will not reveal the complete information about the testing. Hence, we need to proceed with another type of testing called glass box testing. It is path complete. That is, it tests every path in the program. So glass box testing method is also called as path complete method, where we test each and every path of the program. Tests both branches of if statements. If we have an if statement, then the condition of satisfaction, not satisfaction, that is if true, if false, both are to be tested in case of glass box testing. Then the third point, each except class is executed in try except. We have used try except in network programming. So try except is for exception handling. There may be different types of exceptions. We have tried in file server and file client. If the file is not present at the server side, then the exception will be thrown. So that is file not present error, then value error, then divide zero error. There are so many types of exceptions. All possible exceptions are to be executed, not just one or two, whenever we are using try except. Next, whenever we are using a for loop, do the following tests. Number one, the loop is not entered. So take test case, test input in such a way that the system will not enter even once inside the for loop. If the loop is iterating over the elements of a list, test with an empty list. So that's what the loop is not entered means. So if we want to iterate through a list, input an empty list. Second one, for the for loop, body of the loop is executed exactly once. It must enter the for loop only once, then it should come out. The first case, it is not at all entered. The second case, it must be entered exactly once. And third case, body of the loop is to be executed more than once. Normally, if we give all possible inputs and check all three cases for a for loop, we can do a testing of a glass box testing of a program. Next one, for each while loop, we have seen earlier what are the possibilities for if else, try except, for loop, and now for a while loop. Look at the same kinds of cases like for loop. Which are the cases? While loop not entered even once, while loop entered exactly once, while loop entered more than once. These are the three cases that we have tried even in for loop. And second one, include test cases for all possible ways of exiting the loop. So exiting the while loop, when it enters the while loop, you check those three cases and also give what are the possible inputs that will take the system out of the while loop. Next, last one, sixth one, for recursive functions, include test cases that cause the function to return with no recursive call and more than one recursive call. So what is a recursive function? If a function calls itself, then we call it as a recursive function. While testing a recursive function, you include test cases in such a way that recursive function will not be called even once. So whenever you call a recursive function, it should run only once and it should return back to the program which has called it. And second case, you give input, you give the test input in such a way that the procedure will call itself at least once or more than once, so that how recursive function works will be known. So with execution and without execution. Next, conducting tests. So how tests are actually conducted? We have learned what are the different types of tests. Now how tests are conducted? There are two phases of conducting tests. First phase is called unit testing and second one is called integration testing. In case of unit testing, testers construct and run tests designed to find out whether units of code work properly. So each unit, maybe it is a class, it is a function, it is a structure, it is a union, whatever it is. You just take one such unit and do testing whether it's working or not. Second one is integration testing, where the testing is designed to find out whether the program as a whole behaves as per requirements. So here all the spare parts are assembled, then we will check whether the whole system works or not. I would like to give an example of your basic electronics. I want to design a power supply. As you know, what are the different stages or different circuitry needed to design a power supply? The first stage is a rectifier, second stage is a filter, and third stage is a regulator. Normally what we do, we rig up a rectifier circuit separately, a filter circuit separately, and a regulator separately, and check whether it is working or not. Finally, you give the output of a rectifier as input to the filter and output of the filter as an input to the regulator, and check the output by giving the sinusoidal input at the input of the rectifier. You give an AC input, whether you check at the output whether you are getting a regulated DC or not. So the first case is called unit testing, where you check only rectifier, only filter, and only regulator. And the integration testing is one where you see whether you are getting a regulated DC when you give an AC input. So in some companies, development group is responsible for unit testing and software quality assurance, which is called SQA group, for integration testing. The responsibility of unit testing is normally shouldered by the development group, and the integration testing by the software quality assurance group. It's not a hard and fast rule. Normally this is the norm which is followed by most of the corporates. Next, the testing process is often automated. So all said and done, whatever we have said so far, you generate a test suite, give all possible inputs, try all path. Normally it is not done manually. The testing process is often automated, in the sense the testers, instead of typing inputs and checking outputs, use test drivers, which consists of a setup environment needed to run the testing program. So you have a test bench. Like your hardware testing, here also you have a test bench run with predefined or automatically generated sequence of inputs. The inputs will be automatically generated by that testing system, an automatic testing system, and it will give all possible inputs. That means a test suite is already available inside. Save the results of these executions. There is a provision there in the test suite to save the results of execution for all possible input combinations. Check the acceptability of the results of the tests. So you have to do this one. Whether the results obtained after the testing are acceptable or not. Finally, it will automatically prepare an appropriate report which will be sent back to the development team for any modifications required so that it will work correctly. Next is debugging. So far we have studied about the testing, different types of testing, etc. Now the next step is debugging. After testing, if we find the program is not working, even after black box testing and glass box testing, we have to do debugging. So debugging is the process of removing the bug. So debugging is the process of fixing, means repairing the fault in a software. Bugs can be broadly classified into 4 types. There are 4 different types of bugs. First one is called overt bug, second covert bug, and third one persistent bug, and last one intermittent bug. What is an overt bug? The program crashes or takes far longer time to run than it should. So overt bug is one where it will be in a continuous loop. The system is like hang. So where the program crashes or takes longer time to respond. Second one is a covert bug. Here program runs within time but produces incorrect answer. So it's not as catastrophic as the first one. So here program runs but it will not produce the expected result. Third one, persistent bug. It occurs every time the program is run with the same inputs. So if this type of the persistent bug occurs, if we give same input, it produces the same output. In the sense, if I give a set of input, it will not produce the correct output. If we give another set of input, it will produce correct output. The last one, intermittent bug, it occurs only some of the time, even if the program is run on the same inputs and conditions. If I give same input, say at time t1, it produces one output. If I give again the same input at time t2, it produces some other output. This is called intermittent bug. You can see here among the 4, overt bug and intermittent bug are very dangerous. The first one crashes the system, which is really dangerous. And last one, intermittent bug, because it behaves in a very anomalous fashion. So for the same input, it will produce different output at different instant of time. Let us see the next one. A debugging example. I have written a program debug1.py. In the next lecture session, I will discuss in detail about this program debug1.py. Thank you.